In the subtraction problem, the imaginary unit I works just as if it was an x. So we can add the opposite. Now we have 9 plus negative 2, that's positive 7. And we have 5 plus negative 3, that is positive 2 of those i's. This works exactly as if it was an x, even though it's not. Now the directions say to be sure and write this in a plus bi form, which means a number plus a number times I. And we did that. Here we're asked to simplify. Notice we can't distribute an exponent across that subtraction in the parentheses. So the correct way to do this problem, the correct way to start it, is to write it out as a binomial times a binomial. Now we got a 16, and we got a minus 8i, we got another minus 8i, and then we got a 4i squared plus 4i squared. Now that's 16, and this is minus 16i, but we got to be careful with the 4i squared. I is the square root of negative 1 by definition, so I squared is the square root of negative 1 times the square root of negative 1, which has to be the thing inside. And so 4 times I squared will be 4 times negative 1, because I squared is negative 1. And that's negative 4, and those are like terms. So we have 12 minus 16i, and notice it's in the a plus bi form that we need. So we're being asked to divide two complex numbers, and the easiest way to think of that is to rationalize the denominator. And so we're going to multiply this denominator by its conjugate. Since these are complex numbers, it's sometimes called its complex conjugate. It's this binomial with the opposite sign in the middle, so it was a minus, now it becomes a plus. What we do to the bottom, we have to do to the top. So on the bottom, we get ourselves a 9, doing FOIL, this times this, and then we get a plus 21i, and then we get a minus 21i, and then we get a minus 49i squared. On the top, we get a 12, we get a plus 28i, get a plus 15i, and we get plus 35i squared. So on the top, that is a 12, it is a 43i, and it is a minus 35, because remember I squared is negative 1. On the bottom we have a 9 plus a 49, because negative 49 times negative 1 is plus 49, and those i's cancel. And so on the top we have a negative 23. Well, this screen seems to be moving around for no good reason. Negative 23 plus 43i, and on the bottom we have 58. That's a reasonable answer, except if we want our answer to look sort of like a plus bi, then we would need to distribute the 58 to each part in the numerator separately, and we would get this. So let's take some powers of I. So I to the first, I to the second, I to the third, I to the fourth, I to the fifth, I to the sixth, I to the seventh, I to the eighth, etc. I to the first is just I. I to the second is negative 1. I to the third is negative 1 times I, that's minus I. I to the fourth would be I to the third times I, which is minus I times I, which is minus I squared, and since I squared is negative 1, we've got minus negative 1, which is positive 1. To get to I to the fifth, we take this and multiply it by I, and so what we find is this result. And so if I want to know the 42nd power, I'm going to know that I to the 40th power is 1. And then I to the 41st power would be I, and I to the 42nd power would be negative 1. So I to the 42nd power is negative 1. There's fancier ways to do this, but I think for us, for now, that's pretty good. We made a table, and we saw that powers of I that are multiples of 4 are 1. And so we knew that I to the 40th was 1, and then we just had to do 1 times I to get I to the 42nd, because this is I to the 40th times I to the 1st times I to the 1st. And that's 1 times negative 1, and that's negative 1, and we're done.